When an object is dropped inside water, these patterns are formed. The patterns travel from the source and propagate away from the source. These patterns are called waves. In this video, we want to be looking at the concept of waves. Similarly, if you pluck a string, waves travel through the string to the point where it is fixed. You will agree with me that when you pluck the string does not move away from you. While it is still in your hands, you will find it vibrating up and down. Similarly, the water does not move away. You just see the particles of the water vibrating up and down. What it means is that waves are disturbances that travels through a medium. It does not cause a permanent displacement of the medium. It only causes the particles of the medium to vibrate while it travels through it. That is to say, it is not the medium itself that is moving away. It is the wave that is traveling through the medium. The medium itself remains about their fixed position. Following this, we can describe wave or define waves as a disturbance which travels. And while it travels, it transfers energy. And while transferring the energy, it does not cause any permanent displacement of the medium. So from here, you see that the wave travels from the source. The particles vibrate as it transfers energy, but the particles itself are not permanently displaced. They just vibrate up and down about their mean position. You will agree with me that if you put a paper on this water, you will not see the paper move away. You would only see the paper moving up and down. What it means is that the water is not actually moving, it is the wave that is moving. Now that we know what a wave is and we've been able to define it, let us look at some of the terms that are used to describe a wave. Follow me to the next page. The terms used to describe a wave. This is the representation of a wave. You can see the up and down movement of the particles of the wave while it travels. This vertical line represents the displacement of the particles, while the horizontal line represents the direction of the travel or the distance covered while the wave is traveling. Now, you would observe that the vibration is going up and down vertically. However, the travel direction is horizontal. This type of a wave, where the direction of travel is perpendicular to the direction of the displacement, is what we call transverse wave. However, that is a topic for another day. In this video, let's concentrate on the terms used to describe the wave. When the particle is displaced, it rises up to a point, the maximum point. It also falls below to a point, the minimum point. That maximum point is what we describe as the crest of the wave, while the minimum point is what we describe as the trough of the wave. Also, you will observe that this original medium of the wave, undisturbed medium, after displacement, it rises through a distance to a maximum point that we call the crest. It also falls through a distance to the minimum point that we call the trough. The maximum upward displacement or maximum downward displacement is what we describe as the amplitude of the wave. Remember, the crest is only a position on the wave. However, the distance from that position to the original medium or original state is what we describe as amplitude. While amplitude is a distance, crest or troughs are position, are points on a wave. Now, if you observe carefully, from point O through to A to B, it looks like a semicircle. You can say this is half of the cycle of the wave. From B through C to D looks like another half cycle. So, if the wave travels from O to A through B, C down to D, you will agree that it has completed one cycle. Similarly, if it started from E through F to G, that is half a cycle. If it continued from G through H to I, that is another half a cycle. So a wave that travels from E through F, G, H down to I has completed one cycle. There is a distance covered while it is completing the cycle. The distance from E to I is what we call the wavelength of the wave. It is a distance covered horizontally. Similarly, if you started from F through G to H, that is like half a cycle. From H through I to J, that is like another half a cycle. So a movement from F, G through H, I to J That is, a distance from F to J is another wavelength. So the wavelength of a wave is the distance covered in a complete cycle. So you will agree with me that this up, down, and back to this point movement is one cycle or one oscillation, while the distance covered while making that one cycle or oscillation is what we describe as the wavelength. Now let's move to another interesting part. There is a time taken for the wave to have traveled from this point E down to point I. Similarly, the same amount of time would have been taken for it to travel from point F through to J. The time it takes for that wave to complete one cycle or to move through one wavelength is what we describe as the period of the wave. Period, capital letter T, is defined as the time taken to complete one cycle of the wave. Now let's go to another interesting part. If it took 1 second for the wave to have traveled from O to N, you will observe that it has completed several cycles within that 1 second of traveling to point N. In other words, the number of cycles of a wave that are completed in 1 second is described as the frequency of the wave. Frequency, represented as F, is defined as the number of cycles completed in 1 second. Now look at the beautiful thing. There is a relationship between the period and the frequency, because if you know the time it takes to complete one cycle, you can tell how many cycles will be completed in 1 second. Again, if you know how many cycles are completed in 1 second, you can be able to tell the time it takes to complete one cycle. In one of our subsequent videos, we shall be looking at the relationship between each of these terms: the wavelength, the period, the frequency, the speed, and what have you. But for now, we are just looking at the terms used to describe a wave. If you understood all of this and you enjoyed this video, you want to stick to this page so that you will see more description under waves. But for now, try this simple exercise. If the period of a wave is 0.1 seconds, what is the frequency of the wave? Please put your answer in the comment section and I'll be there waiting for you. Once again, thank you for supporting Knowledge Base.